We just saw this linear algebra view of the evaluation of this polynomial a of x at these endpoints x0 through xn minus 1. Now let's look at it for the perspective of FFT. For FFT, these endpoints correspond to the nth roots of unity. So let x sub j be the jth of the nth roots of unity. So it's omega sub n to the jth power. Now let's rewrite these vectors and matrices. Replacing these endpoints by the nth roots of unity, we have now a of 1, a of omega sub n, and so on, up to a of omega sub n to the n minus 1 power. So these are the nth roots of unity. This column vector is going to stay the same. It's still going to be the coefficients of this polynomial a of x. Now let's look at the rows of this matrix. Now the first of the roots of unity is 1. So the first row are the powers of it. So it's just going to be 1. The second row are going to be powers of omega sub n. This, in fact, are just the nth roots of unity. The third row is going to be 1 omega sub n squared, omega sub n to the 4th, and so on, up to omega sub n to the 2 times n minus 1. It's just the powers of omega sub n squared. The last row are going to be the powers of this last root of unity. So it's going to be 1 omega sub n to the n minus 1, and so on. The last term is omega sub n to the n minus 1 times n minus 1. Now, what's the important thing to notice about this matrix? Well, first off, it's symmetric. The entry ij is the same as the entry ji, so it's probably going to have some nice properties. The other thing to notice is that it's just a function of omega sub n. The entries of this matrix are just powers of omega sub n.